let's start the session. I invite Director Dr. Kannan C.S. Wadia for the welcome address.
Good morning to you all. KFRA celebrating its Golden Jubilee from July 3rd to 2025 July. And we had our curtain raiser program on 6th of July, where Advocate K. Rajan, the Honorable Minister for Revenue and Finance Housing, has inaugurated the program. And 2 lectures were arranged during that time. This is a 3rd lecture in that series. Impact of deforestation on Himalayan watersheds. Dr. Chandrasekhar Prasad Ojha is an eminent researcher in the field of civil and environmental engineering, currently serving as professor at the Department of Civil Engineering, Indian Institute of Technology, IIT Roorkee. With a distinguished career spanning several decades, Professor Ojha has made significant contributions to environmental hydraulics, water resources engineering, and related fields through his extensive research, teaching, and leadership roles. On behalf of all staff of KFRA, I invite Professor Chandrasekhar Prasad Ojha to this function. Welcome, sir. And over to the computer.
Thank you, sir. Now I invite Surya for introducing the research.
I'm extremely happy to introduce today's resource person, and he's also my co-supervisor at IIT Roorkee. About Professor Ojha, he has started his academic journey with a bachelor's degree in civil engineering from Gorakhpur University in 1982, and then he pursued his master's in engineering in hydraulics and water resources engineering from IIC Bangalore in 1984, and did his PhD in environmental hydraulics from Imperial College London in 1993. Professor Ojha's professional career commenced as a lecturer in civil engineering in July 1984 at IIT BHU Varanasi, and later he joined as a lecturer in civil engineering in 1986 at IIT Roorkee. Professor Ojha's research interests are diverse and encompass various aspects of environment and water resource engineering. His work primarily focuses on modeling of environmental and water resource systems, flow and contaminant transport, soil moisture uptake by plants, and impact of climate change on water resource management, and many more. Professor Ojha has made substantial contributions to the scientific community through his extensive publication records. He has authored and co-authored more than 300 research papers in reputed national and international journals, published 11 books and 58 book chapters, earning several awards for his work. He has received several notable awards like Commonwealth Research Scholarship Award, Alexander von Humboldt Research Fellowship Award, JSPS Invitation Fellowship, E.M. Curtis Visiting Professorship, recipient of American Society of Civil Engineers Research Paper Awards, and Jal Vigyan Puraskar in many years. He has served as an adjunct professor at the University of Missouri, USA during 2018-20, and as a visiting professor at Purdue University during 2012-13, and also as a visiting faculty at Asian Institute of Technology at AIT Bangkok in 2004. As a mentor and an educator, Professor Ojha has inspired countless students and have guided and co-guided more than 58 PhD students. Professor Ojha's contribution to civil and environmental engineering have earned him national and international recognition. His work continues to influence the field addressing the critical issues related to water resource, environmental sustainability, climate change, and his legacy will endure for generations to come. It's a great pleasure and honor for me to invite you to this lecture.
Thank you. First of all, very good morning to everyone. And this is my first visit to Kerala, and in Kerala to this institute. So that's how unique it is, right? As introduced by Surya, I did my master's at IIC Bangalore, right? So there were many students from Kerala at that time. We had good friends. When I was doing, spending my time in Germany, I met a few friends from Kerala. So it's a good bond base. Okay. So I'm very happy that after a very long time, at least my dream has come true and I'm to this stage, right? Regarding the topic which I'm going to cover today, first of all, these slides are prepared by my students in 2-3 days time, right? Because if the water has to move upward, there has to be some gradient, some suction effect, right? Only through that the water will move. And once the water moves from the soil, the soil moisture will change, right, within the soil, because you are trying to take that water out. So he essentially introduced us to this interesting mechanism of soil moisture uptake by roots, right? And in that process, he developed a linear model of root water uptake, that the plants will extract the water linearly, right, through the root there. That's what he told us. As a student at that time, I was really, that's okay. You can assume that it is linear. But then I was always thinking that how it can be a linear uptake. He said, no, because see, in the root zone, there are different theories. So if you have the root zone like this much, then top 25%, then bottom 25%, like that. So 40, 30, 20, 10 percentage. That was the thumb rule. And in fact, he tried to modify that through that linear distribution. It also worked in some cases. Later on, when I became faculty at IIT Roorkee, that same curiosity continued. And somehow I was exploring that could there be any other uptake law. Linear one, I was not convinced as a student, right? Many times you are young guys, you may not be convinced with what I'm saying. That's how this research proceeds further. So then I was exploring that with my students, and then we took detailed measurements of soil moisture, and at different levels during different periods of the crop growth. And then I came out with a nonlinear root uptake water law, right? Nonlinear law. So based on that nonlinear law, the question was that how that nonlinearity should be quantified, right? Then we started looking into the data collected at other places in other countries, because Western people, if we say something, the first thing is they will say, okay, the data in India might not be collected correctly, right? This is a usual problem. It's a question of building confidence. I said, okay, let us try with their data. They have collected the data, USDA, US Department of Agriculture. We approached them, and we could get data from 28 crops, right? So we live those data and then came out with the perfect this non-linear root water uptake model, right? It's all published. Surya is exploring those models and looking into the potential of those models. So this was my starting point, and that's how, so the credit goes to my guru, Ram Prasad, who introduced me this subject, right? After that, I joined IIT. Now earlier it was University of Roorkee, and then it became, IIT, okay, in 2001. All of you must be knowing Roorkee, and you have been to Haridwar, I hope? No. Please come. So long as I am there, I'll be pleased to welcome you, right? So that's my personal request. Just let me know that you are from KPRI, and that's enough, okay? So now, in Haridwar, when I joined Roorkee, then I met another my late guru, Prof. Swami. He was looking into hydrological part of it. That what happens if you try to decrease the forest cover, how it is affecting our hydrology, right? When you are talking about deforestation, basically we are talking about reducing the forest cover, isn't it? That's what the deforestation is in technical terms. So you have a land area, you have a watershed of certain area. In that watershed area, the forest area may be certain fraction of it. The moment you go for deforestation, you are trying to reduce that fraction, right? So if that fraction reduces, what will happen? Will it have any impact on the hydrology of that watershed? So then I developed interest into it. I said it's very interesting because as a student at IISc Bangalore, I was just exploring how this water is being taken from the plants in the vertical direction. Now this another dimension of this was added when I started looking into that how hydrology of the watershed gets affected because of this deforestation. So again, I would like to remember my late Guru, Professor P.K. Swami, right? After doing all this work, then again I was curious to see that, well, if forests are there, they consume CO2, carbon dioxide, in the process of photosynthesis. All of us know it, right? And then I was reading several articles that, okay, this is the level of CO2 in the atmosphere, right? And this is what is happening to the global temperature. So there was some link between the temperature and CO2. That's well established. You can find such variations, at many places. Then again, the curiosity arose that, well, if CO2 level is changing, if temperature is changing, then it should also affect the transpiration. All of you know, must be knowing evaporation, evapotranspiration. So it must be affecting the transpiration process. Then what happens? How that is affected in the presence of CO2. So this part I explored at Japan, right? I went to one of the labs at Arid Land Research Center and looked into that how in the presence of CO2, the process of evaporation, is affected, and what happens to evaporation when the CO2 level changes to different levels, right? So what I will try to do, and after that, as a follow-up that, we did several, I think three projects based on UK scientist collaboration. And again, several institutes were involved in there. I think one of your scientists who is sitting here, he was also involved in one of the UK project, and I met him there. So that's how, I have tried to frame this lecture, today's lecture, okay? And that is the basic philosophy. And there will be some equations. We should not be afraid of equations because whatever the background we have, at least we can follow some equations. I will cover only that much. And some of the slides I will speak considering the background of many students, so that the lecture could not be a boring one for you. At least you should really see, in a sense, what is happening. Okay. So with this brief introduction, I will go to some of the slides. This is all prepared by my students. So kindly bear if there is any quality issue with any of the slides. Otherwise, that's okay. So some of the slides are quite general. I have seen it. I have just glanced through it. That I will skip and straight will come to the work. So let us see, for the benefit of students, all of you know what it is. This is not a piece of bread or something. You can see what is shown here. So many things are shown here, right? Now, if you see the tributaries, any watershed will have certain network through which the flow will come. This network can be very different from what is shown here, but it will certainly have a network, right? Is it possible that any watershed should not have the network? No, it will definitely have some network, right? It will have some outlet through which the water will come out, right? Now, the way this water flows through the network will depend on if let us say any path is having a larger slope, the water will move very fast. It is so simple as that, right? That's okay. Nowadays, what is happening? If you are going for deforestation, right? And we have removed the forest, it means we have completely changed the hydrology now. And because of the impact of rain, see, if the forest cover is there and rainfall is taking place, the forest will protect from that impact. But if the forest is not there, that rainfall drops with a very high kinetic energy sometimes will impact the surface and they will erode the surface. So a lot of material from the soil will also come with that water. And that in simple terms is known as sediment load. Once this sediment load initially you designed the water course, this network, so the water should get transported through this. Now, because of the deforestation, if you try to remove the forest, you are enhancing the erosion process. And because of that, now sediment-laden water is flowing into this one. So now there is a theory from a person, Lacey. He was in Rootki. And he said that if the sediment-laden water is flowing into any stream, after a long time, it will reach some equilibrium, right? If the clear water is taking place, it will reach some equilibrium, right? Now, if you change the characteristics of water by deforestation, it means you have already disturbed the equilibrium system. So now, the dimensions of this drainage network will not remain same because you are going for deforestation and you expect that everything should look nice. No, that's not correct, right? So you have already disturbed the equilibrium of this network by going for deforestation, right? So not the dimensions of the networks will also change. In hydrology, nobody looks into this, right? You go through the literature, you will find that they will just process the image, remote sensing image. They will create some drainage network, not worrying too much about precise dimensions of the, tributaries in the network, and they will start doing the modeling, right? The basic problem is if anything is changing, if the forest cover is changing, you see how you have changed this network, how you have changed the dimensions. So the travel time to the outlet, which you assume to be something, let us say, in the presence of a certain fraction of the forest, if you remove that fraction, if you change that fraction, everything will change. And nobody is doing that. So I'm happy if you go for the forest hydrology division here, right? You just explore this because you have the facility here, you have the forest here. Just look into it, right? The areas where the deforestation has taken place, how things will change, right? So this is very important, right? So it means whatever this network is there, okay, in the presence of forest, it will have some other network. In the absence of forest, it will have altogether a different network. The same watershed, the hydrology will completely change. So this is something, you must keep in mind, right? So deforestation is certainly going to affect the hydrology, okay, by modifying these, dimensions of this network. So that's the only one thing which I wanted to highlight. So this is a burning research topic. And without this, if you are really talking about the precise estimations of floods and forecasting and everything, this will have very little meaning. From research point of view, I'm telling you this. So those who are doing research, you can think in this direction. Okay. So the purpose of this slide is only to highlight that. Okay. Hydrology of the Himalayas. I won't be going into details of this, but anyway, those of you have been to Himalaya, that's good. Otherwise, you can see Ganga Basin, Brahmaputra Basin, right? The tributary of the Ganga is Jamuna. In fact, I have, dealt with these basins in a greater length in some of my textbooks I've written on Brahmaputra, Ganga, Jamuna. I have covered this. And then we have worked on some UK-sponsored projects in this Satluj Beas Basin. So practically, I have covered I will say, most of the Himalayan basins, right? And last year, I went to Sikkim also to work on Tista project. And you might have heard that because of Glacier Lake outburst flood, right? This Tista dam got completely damaged. You might have seen that, right? The Bureau of Indian Standards has given me the responsibility to chair the national committee. So I'm working as the chairman for the past few months just to look into Glacier Lake outburst floods, okay? And we are working towards that. But that's not the purpose of this one. What I'm trying to say is that even many stretches in Himalayan watersheds, deforestation is there. That we have seen personally. If you go through the published papers, and if somebody reports to you that there is no change in the forest cover, at least I'm not going to believe it, right? I will believe what my eyes have seen, right? So I request all of you to visit some of these interesting places. Okay. Okay. So you see here the figure of forest cover from different countries. This is not done by me. The source is given here. Right. So such statistics, if these are correct, right, they will tell us that, okay, the change is only this much percent, right? That's the problem with the statistics. Okay. Change is only this much percent overall. But that overall change can be also because it's in certain parts you can have more change. This is the average figure, no? Average figure. Average figure will give a very wrong perception of something, right? So in a certain part, let us say you may create 100% change. You go for complete deforestation. And it will look like, oh, only 1% is changing there, right? But at least one part you have completely disturbed, right? You have completely changed the network, completely changed everything there. And so collapse will take place from there, right? So the localized problems will be there. If you are, let us say, constructing some roads or some infrastructure there, what happened to Simla last year? You must have seen in the news. You know Simla? All of you know Simla? Simla is a hill station, right? Very famous tourist place. And people went for, constructing buildings, went for deforestation, because if you are constructing a building, you will find some space. It's not like that within forest you are constructing something, right? So they just try to do all kinds of engineering interventions. And so they didn't localize the area. Though it may not appear that, okay, the forest change is so much, it's only change little bit, some percentage, because you are considering a larger area. But in that particular region, in that particular Simla city, you created a lot of change. While computing the average, it did not reflect. The moment you take India, this is the situation of forest change, that's very dangerous. So such kind of statistics, Pakistan this much, India this much, this I don't trust it at all, right? This is not India. India, if you say the percentage change is this much only, at some place that change is so significant, the people living there, they are going to face the problem, and not India as such, right? So this is something very important. So we try to usually, this language is good for the leaders, right? They will say, this much change has taken place in India, nothing to worry at this stage. India is not going to face the problem. A certain part of India is going to face the problem. So we have to be very careful about these statistics. We should see ourselves what is wrong, which is going at any place, and we should try to rectify it. Now we know that deforestation is not good for us. Then why are you permitting it, right? So that's the kind of care which needs to take, right? Not this overall very few. Oh, change is only 1%. Oh, we are happy. We are happy. Where that change is there? This 1% change in the statistics for the entire India may mean 100% change at certain part of India, right? So we have to really very watchful that what is happening. That's what I'm trying to show. So really, I don't believe in these statistics, right? Okay. So this is the one thing I wanted to highlight. Some human actions and all these things, this we know already, right? So you can just have a look at it. I don't really believe, explain all these things. Okay. So we have seen that how this forest cover is affecting the things. Just to make the story very simple, I will take you to the Port Blair. 2 years back, I was invited by Public Health Department. There was a crisis in Port Blair regarding water supply. And there is a Dhanikheri Dam, right? So I just went to inspect the entire watershed in the Port Blair. And then they started showing me removal of forest at many places. And again, the damage to these networks. And this water finally, with the sediment, reached to that Dhanikheri Dam reservoir. All of you know reservoir? Anything behind the dam? The pool of water body? And this started getting deposited there, right? In the reservoir. What will happen? If the deposition is taking place, the reservoir will lose its capacity with time. So it happened. And there was alarming situations. A decade back, then the government decided that, okay, now we raise the level of the dam. So they raised it further. so that the more water could be there. Now, when you try to raise the dam, the possibility is that whatever the forest cover area is there, you are trying to submerge everything in the water. So it means so much damage is already taking place. You are playing with the ecosystem, right? Your forests were initially not submerged. Now by raising the dam, you are trying to submerge everything. That's not correct. And if you submerge any organic stuff in the water, what will happen? All of you know about the methane. There is a lot of research going on that from these water bodies, how this methane propagation takes place, right? Organic reaction, right? CH4. So any organic matter in contact with this, the release of CH4, the process of anaerobic digestion will take place, right? All these things happen. Without going into complexity of all those, then what I looked into Port Blair is that complete damage to the forest in certain places. From that damaged portion, the continuous supply of sediment, lead and water to the reservoir. And I told them to take proactive measures. Otherwise, this is not the solution that every time you are getting this problem of siltation in the reservoir, you just try to raise the dam level. That's not correct. So I gave them some suggestions and told them to remove that silt also, whatever has deposited. But that's only curing the disease at that point, right? The main problem is, if you want to deal with the problem of siltation in the reservoir, it's not that whatever silt is there in the reservoir, you just try to excavate that and throw it somewhere else. That's not the solution. That's not the correct approach. The correct approach is that look into the watershed, look into where you have tried to deforest the things, and try to restore that system so that the process of erosion is controlled and ultimately the silt into the reservoir is controlled. So that's what it is. So we have to really look into this. Now, some of these, you see, canopy interception, evapotranspiration, soil infiltration, certain general things, downstream precipitation and water supply. Of course, I have told you the way about the water supply in Port Blair. So how this affects, right? Okay. Okay. Now we did some work regarding water quality degradation. I'll come to that later. Not now, but this could be some of the impacts of deforestation and environment. So I will show you that. Okay. Now everything is happening here. Altered hydrological cycles. I've given you a framework for that. Increased surface runoff, reduced infiltration, right? All of you must be familiar with the infiltration. Whatever goes down in the soil, that is infiltration. In simple terms, runoff which flows over the surface runoff, and evaporation which goes into the atmosphere, right? So, and this also we have discussed soil erosion and sedimentation. So I briefly touched these points, right? Okay. Water quality degradation, of course, you can see we have also indirectly talked about this one: habitat loss, increased sediment load, climate change implications. Anyway, and so ultimately, the forest improve water security. That is there in essence of all this, right? Now let us come to the sum of work which I did at IIT Roorkee and Japan. I just wanted to include that also. Okay. So I'm keeping this my lecture not to be very highly mathematical or something. I'm just keeping it with the purpose that all of you get a real feeling that how this forestation is important and how this deforestation is harmful to us, right? So far, I've just tried to highlight that only. Now, if you just look into the work which we did at IIT Roorkee, now, name of my late guru, right? I don't know why my students have put T before my name, right? Maybe because the T has come, just to be on the lighter side. And one of my students, Ali Abbas, right? So he was master student. And we collected the data from Central Water Commission in India, right? And you can also see Kerala here, right? So all this data, we analyzed that, right? Mean annual flood. We had the data from Central Water Commission, and we just tried to look into that how this could vary, right? And is it really important for us to bring in somehow the impact of forest cover into this? Okay. So that was the intention, right? So with this, we did some mathematical work. Without going into detail of that, we came out with the equation of how to compute the mean annual flood. This was published in this journal. If you want to see in detail what this paper is and what are the other things, you can certainly go through it. But the purpose of today's lecture is just to give you a feel of this, not the real mathematics behind it. Okay. So finally, what happened? No. Yes. So this is the equation we proposed. P is there, P for precipitation, right? T is their return period. The flood will have, like I said, 25 years you will have some flood, maximum flood. In 100 years you will have some other maximum flood. T is for that. S is the slope of the catchment, mean slope of the catchment. And what is interesting here is forest cover, CEF. CEF, right? Now if you see, if you try to do the simple analysis, if P is more, Q is more, no problem. We agree. More precipitation, more flood. If A is more, area is more flood, right? If the watershed area is more, you will have more flood. Mean slope, okay. What about forest cover? The CF is there in the denominator. If this becomes 0, what will happen? Simple mathematics. If this becomes 0, the denominator CF becomes 0, the forest cover becomes 0, then this Q will increase. See this one? And this is based on the data analyzed from all over the India, right? So, and this is the other out my results, right? So this is forest cover fraction as a ratio of this entire area of the watershed. So if you try to reduce this, you are certainly going to increase Q. There is no problem in that. And this is how this equation works. And it works not only for, catchments, watersheds in Himalayan regions, even for your Kerala catchments watersheds have been also considered in this one. So it works for everyone, right? So this is the work we did in 95. And this was the work perhaps highlighting that what is the importance of forest cover, right? In terms of the simple logical applications. Because any engineering structure you are going to design to face certain Q values. Whatever the flow is in the river, based on that, you will only design the piers, you will only design the bridge which is going over that, right? So any infrastructure you are going to consider, this is a very important one.
So what's the difference between the first and second equation?
Oh, first and second equation, A in kilometer square. Oh, I think the student has not mentioned this. It must be for a certain value of D and T, this equation will be there. Yeah, okay. So students, note, I told you that this is done by, the first one is the most general equation, right? The second one he must have copied, depending on what is the value of D and T is there, right? So that's how the second equation is come. Because that's the difference between first and second equation. D and T terms are not there. So if you just put certain value of D and T in that, certain duration of precipitation, certain return period of the flood, then this will be this equation. So it's simple. But the first one is most important one. You can go for any choice of D and T and you can get different forms of each one. As I told you that I was traveling and I was just, so that's okay. So it's good point anyway, but you can read this paper. There the value of D and T will be given for which this equation is there. Okay? That's okay? Right. After this one, yeah. This is automatically jumping. Okay. Yeah. Some work, as I told you. Right. And basically, there are two kinds of work, in Japan they were doing at that institute. One was, we published both the work. One was, that they had big towers, and from that, they could try to simulate rainfall, right? And the bottom, they used to have different surfaces. And they had some, sensor-based equipment which could sense the velocity of the falling drops as well as the diameter of those drops, right? So this is a very interesting setup. I don't find it in India. I have visited several institutes, must be somewhere. But in USA also I have seen such type of rainfall simulators. In India, we'll have simple rainfall simulator. This will be the surface, and maybe within 1 meter they will have the drop. That's not the real rainfall simulator, right? So if you want to really see that how the size distribution of the drops is there, what is the velocity of those drops, all those things, they can be done only when you have rainfall simulators, real rainfall simulators, right? So in Japan, I was lucky to get one, and we really looked into that. What is the distribution of raindrops and what is the velocity associated with? We published one of the related papers in this one. But that's what that I'm going to cover now. What I'm trying to say is that if the forest cover is there, no matter, let the higher energy of the raindrops be there, it will impact the canopy of the, right? The canopy cover, the forest top, it will impact there, and then it will come downward, right? So that impact is not going to create any adverse damage to the soil surface, right? That's the part I'm just highlighting. Here, this was based on, the carbon dioxide concentration. So they had a controlled chamber experiment in which they were having the facility to vary the carbon dioxide concentration, also to regulate the temperature, right? So all these facilities were there. So my curiosity to see that what will happen under different conditions, I just tried to did experiments there, okay, as a part of JSPS program. And these are the different distributions of T on the, this is also published in this journal, Atmospheric Environment. Again, I should have expected them to put the year and everything. They have not done that. So that I will pass anyway, right? But it is published around, anyway, I'll give you the year anyway, no problem. So this is a good journal, Atmospheric Environment. Then in this entire work is, published. And here we are doing the experiments, and one is temperature, and the other curve is relative humidity. You see, there are two curves here. This is the way temperature is changing on day one, and this is the way relative humidity is changing. Those who have worked in the area of how the process of evaporation takes place, Dalton's law is there, right? When it says that if there is a deficit from the saturated vapor pressure, right, and the vapor pressure which is exactly this, because of this gradient, the water moves upward, right? This is Dalton's law. You must have studied that, very basic level, in 10th or 12th, it's usually covered. But here we try to vary it in the controlled chamber, right? This temperature in a given manner. The temperature distribution, if you see it any place, usually we try to assume that this is a mean temperature, because we don't want to go into, the trouble of really monitoring hourly, distributions of the temperature and this thing, humidity. But you please see that if something is changing hourly, all the time there is change in the temperature, humidity. So will you not expect the evaporation will change, will also change hourly? It will also change hourly. It will also change hourly, isn't it? Transpiration will also change hourly. But we really don't want to do it because we want to take judgment on a daily basis. Also, the data collection effort is also, time consuming. So,
Second and fourth day.
Yeah.
Why did the temperature go up at night?
No, this is the values are written, T. The T is on the y-axis, and the red one is relative humidity, and the other curve is temperature curve.
Yeah, so in the second and fourth day,
Yeah.
during night,
Yeah.
temperature is going up.
No problem. These are the experiments done at different times. Now, what is the minimum temperature is going? You see this one? Temperature 20, 10, 0. It's not negative. You see this?
Okay.
The temperature is only from 0 to 40. So the night, whatever it is showing a certain variation. So daytime, usually the temperature will pick up. In the noon time, mid-noon time, it will be high, go down. So this is following the cycle. Okay? This is following the real cycle, which may happen in the nature. Right? Now the actual observations may deviate a little bit from this one, but this is the usual trend. We just reproduce there. Okay? Now, so there are different patterns here. Different patterns are given here. But to see, sometimes the temperature is rising, falling, rising. All this we reproduce there. And And this is, we just wanted to see that if you try to introduce different types of profile variations, what happens? That was the goal, right? It means all these profiles will not really occur at any place. The most common profile will be that noon times it will be more, right? Night times it will be less, right? So this is the most common profile. But as a, just to see that what could happen in different situations. So we just try to introduce this, right? Okay. So, but you see, these are the cycles. These are the cycles. Okay. And regarding humidity, again, you see these variations. The red one is relative humidity. How this is varying. Okay. And temperature profile, of course, I have shown here. So this is what the sequence we kept, right? Okay. And this is they're the old photographs of this one. Okay. No problem. So you can see the light source was there from the top, which was regulating the temperature. Chamber views there. And so we did this experiment, and very sophisticated ways of measuring the loss of water from the pan. We put a controlled pan there, right? Now, this is what we observed for the day one. These are the actual measurements, right? At 400 ppm and 600 ppm. So, what is happening at 600 ppm? If nothing changes, certainly evaporation is more in the, nothing changes. Only the carbon dioxide concentration changes. So we showed this, that this is what is happening, right? If the CO2 level goes this much in the controlled chamber, this will what happen. One thing is sure, that this is changing the evaporation. It's not same in both the cases. So this is what we observed, right? And we did repeat it, right? It was repeated several times. And every time we found that the more the CO2 concentration is there, evaporation is certainly more than, at lower level. And this is what people are trying to say, that go for forestation, right? So that CO2 levels come down. This is good for us. We should not worry, oh, so much increase is there. In the graph, it does not look to be too much. But try to realize that water scarcity situation. Are in a situation to, enjoy this music, this kind of music, that let some water go evaporate. You try to see over the time, different time periods, how much loss will be there. So much difference is there. That's in a day. Multiply it with the months, years, you see how much loss will be there. Just try to imagine, right? So that's why it's very important that whatever the, our talks are right now, focus towards controlling the CO2, regulating the CO2, going for forestation, they become highly relevant, right? This one figure itself, difference is there, no? Difference is there. And it shows that with the more CO2, more evaporation is there. Now, you should not look at the two curves, very close to each other. No, very close to each other, but you consider it terms of the time scale, area scale, entire globe you consider. Here in the chamber you started, just try to see how much the net quantity it will become. Okay. So this is what we observed. Now other are the things related to this one. What happens to the variation of pressure, some mass transfer coefficients. Don't worry about this. Okay. And here we considered different stages and which stages give the good match with the computed one. So it's a part of research where we also try to, very interesting. I showed you what that research was. Food and Agriculture Organization, FAO, must be familiar with this name. So they try to list down certain procedures of computing evaporation. And there is a term ES, saturation vapor pressure, minus actual vapor pressure. And how this actual vapor pressure is computed, EA. Again, there are three approaches suggested by FAO, right? And we really didn't agree with that where these three approaches should be used. under what conditions these three approaches will work. So in many of my subsequent publications, I just looked into FO procedure and how to use a correct strategy to compute actual vapor pressure, right? So this was also the focus of this one. Yes. This is another work, very interesting work. So I think that we have followed the earlier one, right? In this work, what we try to do, if the forest cover is there, and let us say wind is blowing, and some water body is there. You see this water body here? This one? The pine is there. Pine can be rectangular size, square size, circular size, anything. And in the upstream, you are having, these blocks. These are known as roughness blocks, right? So if some tree is there in the upstream of a water body, and you allow a certain flow, wind flow is there with a certain velocity, how that forest presence of this roughness element is going to affect the process of evaporation from the water body. This is a very interesting problem with it. And again, we try to show the importance of forest in this one, right? So this is the way we created artificial forest. In the wind tunnel, actually, you cannot deal with the actual forest, but certainly in terms of the roughness elements, we try to create this and we try to investigate this further. The reference to this paper is there. You can read more about it, right? Okay. So detailed analysis will be there. Students have just put it. I'm not going to consider any of these slides because the essence I have given that what this paper really talks about this one. Okay. So these are the detailed analysis. Just ignore these figures and let us. Okay. So again, the shape of the water body will have the difference, and E is the roughness element size. And you see at different elements again, the evaporation will change. Okay. So this was what was the work we reported long back, right? Okay. So we did some of the work to understand the interaction with the CO2 and how the presence of a forest affect the evaporation from the water body. This is the work we did. Okay. The first work was really on the quantification of flood, mean annual flood, where we could also realize the importance of forest cover, right? So these three examples, three publications which we had, I tried to explain the importance of forest cover, okay, and how this deforestation is going to affect everything. Now, this is a very general work in which we are trying to correlate. This is a part of Indo-UK project, and we try to collect data from different parts of the Ganges basin and water quality measurements and forest fractions. And finally, without going into the remaining slides, I will just highlight one slide. This paper you can go through this one. I will only highlight this one. Now here what it shows, this is overall index of pollution of any water body. And here you see how this forest cover comes into the regression relationship. Right? So this was very interesting. So overall index of pollution, if forest cover is more, forget about other things. What will happen to overall index of pollution? It will reduce. This is negative sign. If forest cover is more, this will reduce. The quality will be also better if the forest cover is more. So this was a very interesting finding from the Ganga basin, right? Where we tried to analyze and we developed, this kind of relationship. So that was the most interesting, part of our observations based to this one forest cover. So this is the fourth work, right? Which really highlights the importance of forestation. Okay. So this is the fourth work. Then after this, we went for this is published in this one, must be familiar with this journal. And then I was looking at this, for this project, I was the Indian coordinator. So many, IC Bangalore was also partner. Each one looked into different aspects of this one. And the objective was that we should try to develop a whole system model, right? That was the focus. That if the forest cover changes in that one, what will be impact? So integrated, whole system model was developed for Satluj Byas basin, one of this one, so that you can vary anything in that, and then you see the impact of that. So that was the main contribution of this work. So I think these are part of Satluj Byas basin which are indicated here, and this is the whole system model where we are trying to represent everything here. So river is there, aquifer is there, groundwater, there gauging stations are shown, urban water demand is there, command area is there, water demand, okay, interbasin transfer if it is taking place, that is also there. So detailed whole system model was developed as a part of this project. That's what I wanted to see. So I'm not sure if you are having any such type of model, let us say, in your state. I'm not sure. Maybe I have to interact with Sudhir. I know Sudhir, he is a good friend of mine, right? So I will ask him whether you have been, because he is heading this, I think some water resources secretary was there or something, So I'll just check with him, okay? If he has taken such kind of initiatives for the state of Kerala also. It's very important. Such type of whole system models will be really helpful, just to see the impact of individual changes, whether you make in the forest cover or, demand or how to regulate the floods. I think you had some serious flood issue few years back, right? So those kinds of things can be studied if you have a whole system model. So I think people can work in this direction. So I think these are some of the things I wanted to highlight. And I will now show you the photograph. I think I've taken much time. I'm sorry. Because it's okay. Yeah, okay. Because I was told maybe confining to. I'm a professor, no? That's the problem with the professor. Someone has to stop them immediately. Sir, your time is over. My students will always, look at the watch. And then I'll realize that, okay, time is over. But here, nobody was looking at the watch. Thank you very much for paying attention to my lecture. So anyway, so just show you, some of the changes in this one. Students have sent this. Maybe without going into and the rainfall changes. Okay, see some of the damages now. Okay, the entire lecture has been very pleasant so far, just highlighting the technical things, but just to please your eyes. This will not please your eyes, in fact. Okay, they will open your eyes that what is happening. Just see some of the collapse. Okay, and see this. So and see so much loss. And this is the scene. If you go to Himalaya, I have seen there lot of damages. And these damages in Simla, right? What happened after that? So I'll just close it here. I don't want to show all the damages because there will be a lot of pictures regarding this one. But see the engineering interventions. Now what they are trying to do. So those roads were damaged. Now see the first figure. This is a completely road section, completely damaged. And no space to, go for, construction of road because the entire part is damaged. So what they did do there? They, from the bottom, they raised the pier. And the top of the pier, they had a bridge sort of thing. And how that road was restored again. So see how much penalty they have to pay? Constructing a bridge, you can imagine the cost. Must be few crores. It will be in terms of crores only, right? So you cut the forest. You thought you will make some money out of it, right? How much money could you make? Or how much infrastructure, you generated, or how much growth you could do really in terms of economics? If damage at one place had taken place and so much, money you are spending to construct a bridge and construct a certain stretch of road, you just imagine this. So this is what they did. The second one is more interesting. Again, it's similar to Chandigarh. Here, they had no space. They completely filled the soil and tried to put it, strengthen it, right? See how the soil is being packed with this one. See the frames here. How much reinforcement is there? They are just trying to compact everything, right? And the road is going on top of that. How much money is spent here? So we have seen these two places, how much loss to the property has taken place, and now the movement is taking place over this raised road with so much jacketing so that no failure takes place. So this is the consequence of this one. So this picture I thought, I should show you, right? So this forest are, you just cannot quantify that this is the worth of deforestation, right? You see, this is what is happening. This is the right projects. I went with my students to show them. Let's see how much money government is spending now. And what happened? They just removed some part of the forest from the mountains and this thing. And see the penalty now. Penalty is huge compared to whatever the loss we incurred or whatever the gain we incurred in deforestation. Compared to that, the loss is too much, right? Okay. Another situation in Punjab. This is a bridge, Chakki Bridge. We did some project there. You know what happened? Because of deforestation, the water which was coming in the river, it was coming with such a huge velocity that the river bed, you see here the river bed, it started cutting the river bed. And so they had to invest money. They are putting the, cemented blocks here, concrete blocks here, just to allow that flow to that one. Otherwise, it will the complete bank, they have cemented it. Bed also they cemented again, the damage took place, no problem. This is the recent picture. I mean, just went, I think, 1 month back and I took these pictures. So this is the kind of thing. And here you see, this is not a river. The second one is more interesting. Here, this is a river bridge. On the top of that, you can see a road there. Road is going. And the velocity of the flow in the river is so high that, the bridge in the downstreams, they were completely washed away. So then we had to control, and we designed these are known as steps. We designed a system of steps so that when the river water flows over that, the energy of the river water, flowing river water, gets reduced, right? When you come downstairs, what happens to energy level? The energy level goes down, isn't it? Same thing happens with the rivers also. If they travel downwards through these steps, energy of the flowing water will be reduced. And this is what we actually designed it and implemented it. This is constructed now. Those of you get opportunity to visit this place in Pathankot, you can just see this. This is a real implementation. So this is how we are controlling the high energy of the flowing water. So again, the consequence of deforestation of this state. Okay. So see the penalty which you are paying. If you have to construct such huge stepped structure in the river bed, how much money is involved? If you try to pave here, it's at the top of this, a bridge is there. If you try to, completely cement in the bed and banks, how much the penalty we are paying, right? So this I included few slides just to highlight that, okay? And there is one more slide in the last, okay? But that's not from this is from the Himachal Pradesh, but I just included one from UP where we recently visited. And because of the high sediment loads in the rivers, this is simply because of the, deforestation somewhere in the upstream, river has become so furious, it is attacking the banks, and they were trying to construct Ganga Expressway, right? And then they approached us that every time we are trying to, construct this one, the river is cutting the bank. So try to do something so that the bank is protected and Ganga Expressway work is completed. So recently we have completed that work. So this I just wanted to show you that lot of engineering interventions are being done these days to meet with the challenges posed by the flowing river waters, devastations around the roads, infrastructures, landslides. So this has been the consequence of deforestation in Himalayan watersheds. There is no doubt about this. I have several pictures to show, but I will just try to summarize here that the government has been instructed. Recently, I participated in the meeting of Chief Secretary with the different IS officers in Himachal. They invited me, and I told them that you please try to see that in your region, whatever it is, you try to give the importance to this forest. Okay, that's our supporting element. If we try to destroy them, I don't have to say it in a blatant way that they are going to destroy us. This is going to destroy us. So we have to give respect, we have to give dignity, whether the religious means or whatever it is, we have to show some respect to the forest, right? Don't try to go for deforestation, right? And then otherwise, you see how much, the penalty we have already paid and we are going to pay, okay? So with these few words, I will just try to, with your kind permission, the director Saab is here, I will try to stop my lecture. And if there is any point to discuss further, I think whatever I have discussed, I was told that the audience will not like much of mathematics. I have tried to avoid that. I have tried to make it simple, right? Okay. And I hope all of you must have got some essence from whatever I have presented here. So with this, I would like to conclude. Thank you very much. Some of the references are here, and the PPT will be available. So those of you can take it. Some of the students who participated in this one, my PhD students. So they helped me with the preparation of these slides. Okay. So thanks to them again. Right. So with this, I think that's okay. It's a pleasure to be here. Right. Thank you very much. Yeah. Yeah. So now I can take tea. No problem. It's a, yeah. This I won't take. Yeah. Okay. Directors have anything more for me to say? It's okay. Sorry, I could manage in time. Oh, you told me to be, okay, little bit delayed, but no problem. That's okay. Yeah. So you can share these slides to the people who want to explore further in this area. They can use the references cited here. Okay. So I think that's okay. Yeah.
I have one question.
Yeah, sure, sure.
Actually, I'm from Gadwal, Himalayas, and in last few years, it is observation that now water is available in every tap in the home, but water is not available in the natural sources. So, have you observed this kind of thing? Why it is happening?
See, in the hilly terrains in the Uttarakhand, in fact, I did not want to say that. We established Indo-German Cooperation Center. I was leading a this Indo-German project, and in 2007 we established that center. I can show you photographs of center. It was inaugurated by me and the German professors, and that is still working. So if you go to Hardwar, you just visit this center. They are just trying to look into it. Now Uttarakhand state as such has several issues. In most of the places, the source of water supply is, along the rivers, they will have some wells, and through that, for example, in Srinagar, in many places, they will try to obstruct the water. Now, if the flow in the river, natural source, if reduces, still there will be some water in the subsurface part, and they manage. In the upstream reaches in Uttarakhand, there is a problem. At many places, they had boulder-filled galleries. So, because of deforestation, again, the flow became more, and many of these boulder-filled galleries, they got washed away. In mountainous terrains, we do not have much space to go for a development of a full-fledged water treatment plant. So that is the problem. So in fact, I'm involved in several of the water supply projects which are being there. And so your question was that the water is in every tap.
Water is available now in taps, every home through this. That means, but there was a time when all the village people are taking water from the natural sources only.
Natural sources only.
Natural sources are drying.
Yeah, drying up. Spring flows are also drying up. Recently, we did publish some work on spring flows. That's the problem. I think I was told that Sumit Sen was also here. He works in the area of spring flows, right? So that is there. So we have to, we have to face this beauty.
What is the reason basically for this drying up these sources, natural sources? But water is available in taps.
You see, so many things are happening. Regarding, you see, the glacier retreat, temperature is changing. Because of that glacier retreat, maybe the glacier is retreating. And now the pattern of the flow in the rivers also has changed. Okay. So in the summer months, you will get, melt from this glaciers, and that water will go. So if you are not trying to look into that, how much is the incoming water, how much is the outgoing water, how much is the demand, if you just do not try to, and if there is some deficit, right? And if you do not try to replenish that, then this problem will come. That's why the water resource engineers, the prime responsibility is that in your region, you just try to look into how much is the available source, how much is the demand, whether groundwater level is going down in many places. You must have seen that in Punjab, Haryana, Rajasthan, at many places, it has gone very deep in Delhi also, right? Sometimes the depths have been of the order of 60 meters. And sometimes we do not take engineering decisions correctly. For example, I was involved in Delhi Jal Board's one of the committee, the judge appointed me. And there I was looking into, they were doing harvesting schemes. They were trying to recharge the water. I told them, you are not designing your this harvesting scheme in a correct way. I said, why? See, if let us say this is some area, and I am designing my harvesting scheme somewhere. Now you have to see that which way the groundwater is flowing from that region. If the groundwater is flowing from an area and you are just trying to, install your harvesting scheme there in the outflow region, the water will not stay there. It will go in the other direction. And this was what was happening in the. So there are several regions like this. So I think the scientific intervention should be there to properly see the balance of water resources, the demand. If you are trying to do the recharging, are you doing it correctly? Right? All these things have to be seen carefully, because you are talking about spring flow reduction. So if naturally, if you are trying to take something more from that system and trying to reduce the groundwater levels also, you don't expect that, spring flows will continuously, be there and you'll be able to sustain that, right? So over exploitation of the resources, I will say, lesser supply, maybe controlled regulation. These will be all important parameters to consider if you want to sustain in a longer way. Okay? Yeah. Okay.
So can I ask a question? So you told that your data shows that when the carbon dioxide level increase, there's an increase in transpiration,
Okay.
evaporation.
Evaporation.
But is it true for evapotranspiration also?
So evapotranspiration, evaporation from the soil will be there.
Yes.
Transpiration from this one is there. Now, when you are trying to compute the transpiration, even if you are trying to compute the transpiration, you are using Penman-Manton's equation, right? So ES minus EA term will be again there, right? So if there is some influence of CO2 with the temperature, that will ultimately reflect in that.
Yeah.
Yeah.
So second question is regarding the study in Japan on the size of the raindrops.
Mm.
See, like for example, 25 years before,
Mm.
when I used to go to the forest, and if it starts raining,
Mm.
I move to a bottom of a tree.
Mm.
I will never get wet.
Mm.
I have
Mm.
close to the tree trunk
Mm.
for at least quite some time.
Mm.
But now it is not possible.
Mm.
I'm immediately getting wet. Because basically we have the broad-leaved forests, trees, and when the droplet size increases, the leaf just flips off. The rain just strikes me.
No,
So,
this is very interesting. Huh?
So,
Okay.
what is your experience in the study of the size of the raindrops?
Size of the raindrops, if in native there, I can open my paper and then I can tell.
Okay, that's fine.
Yeah, that's okay.
So, another
Yeah.
question is regarding the sedimentation. How do you expect the difference in sedimentation of this Himalayan rivers, which is fed by the ice caps, and the rivers which are monsoon fed in the Western Ghats? Will there be a big difference in the sedimentation and also the siltation in the dams there?
No, have you come across any such data?
No.
Has somebody measured the sediment concentration in the rivers?
I have not come across anything.
So the only thing is that depends on the nature of the surface. So if some impact is there and different kinds of surfaces will be there. So if the surface is, let us say, sandy material or clay material, whatever the type of material it is there, the erosion process will also depend on that. If it's a vegetal cover, the impact will be less, right? So again, that sort of thing you have to see. You just cannot generalize that, this is the concentration and, based on that, we cannot say anything.
You show the pictures of the big damages happening on the slopes of the Himalayas. But Himalayas are a mountain set and Himalayas are rising. Has that got something to do with this major catastrophe?
If you go to Himalaya, go to Himachal Pradesh, see the way the massive constructions are taking place. People will just chop it vertically, right? And if you are constructing a road, right, the second problem, one of the interesting problem I observed is that the drainage system, you have to take that water, no? Either the water will flow from the top of the surface, or there should be a proper drainage system which will go and flow through the subbase of the road. Because road, if you see, it's a, if you see the road construction, you will have compacted soil on the top, it will have this bituminous layer and all these things, right? If you do not try to take the water, drain the water in a proper way, what happens? That water will flow through the subbase, right? And then in the loose soil, flowing water, it will collapse. So that's the thing. So we looked into all these things, and then we suggested somewhere the drainage systems were also not correct. Somewhere, the downstream drainage was not proper because they tried to design culverts and the flow increased. If you have designed a culvert to carry a certain flow, as the flow has increased, what will happen? That culvert will not be able to pass that flow. So there will be accumulation of flow in the upstream. So that's the one thing. Second thing is that below the culvert, they tried to construct steps to take that water safely downstream. That also did not happen, right? Because if the flow is more, the steps will have certain capacity, If the flow is coming with a very high velocity, some of the steps will not dissipate the water at all. It will just jump, right? So all these kinds of problems were there. We submitted, I think, 150 pages report, considering all this, that why this failure took place and what should we try to do there. Okay, so I think.
Last, there's no question, comment.
Ah.
The first paper which I came across
Ah.
on this particular topic, the
Ah.
relationship between deforestation and impact on lower land, was by Frederick Engels,
Ah.
1876.
Right.
He gave a case study of the Spanish planters going to Cuba
Mhm.
and they burned the forest.
Mm.
And the reason was that they had coffee plantation down below.
Mm.
So they wanted the fertilizers to come to the coffee plantation, which will enhance the
Mm.
productivity. But what happened was that in the tropical torrential rains of Cuba,
Mm.
then the soil came down.
Mm. Mm.
The rock was exposed.
Mm.
So Engels was trying to tell that, see, if you're going to maximize your productivity, you're going to lose at the end of the day.
Ah.
So,
Yeah.
so it is 148 years, maybe 150 years.
No,
after-
same thing. I don't know how much they are gaining due to deforestation. Tremendous loss. The property. So much we are paying the penalty.
One lesson which we have learned in Kaifari is that we can only work with nature. We cannot
Yeah.
work against it.
Yeah.
Talk was really reinforcing that.
Yeah.
Thank
Yeah.
you, sir.
Yeah. So it's good that I came here. It's nice that I could meet. I could have met some of you personally, and so just after the lecture I could discuss more. So that's good. That is all. Anything more for me?
Thank you, sir.
Okay. You want to ask something?
Yes, sir.
First, tell me your name so that I should know your name also.
Yes, sir. I'm Balakrishnan from the Wildlife Biology Department.
Okay.
My query is regarding the conflict between the civil engineering construction, especially in the forest areas, and wildlife conservation. So you mentioned the issues in the East Valley, and I never visited the valley, but I'm very
Yeah, I've done
familiar
that.
with the
Yeah.
situation there.
Yeah.
My three
Yeah.
PhD mates did the work.
Okay.
Especially on the impact of hydroelectric.
Right.
outputs and
Yeah.
wildlife.
Yeah.
We also have around 80 plus dams in Kerala similarly.
Right.
Many of them are reservoirs within the forest system.
Ah.
So we never included the wildlife part
Right.
because the movement, the migration, the breeding all disturbed.
Mm.
Now, in the context of climate change, as you know, in South, there is not much difference in the overall rain, but the number of rainy days are decreasing.
Mm.
Within one day, we are getting big rain.
Big rain. Yeah,
So
that's the problem.
This is really affecting the top headwaters.
Mm.
And many of these headwater streams are having many species like amphibian species. They are endemic to very small headwaters.
Right.
So their life is really threatened. Survival is threatened. Now the forest department is coming with several constructions, and though some of them are called as natural, like the freshwater brushwood chip dams, but they are almost equal to the cement dams only. So there is a big conflict. Pawan is also working on supporting the department in some of the work. So there is a big conflict between the conservation and this construction. So what is your take on this and any suggestions? Yeah, that's my guess.
No, see, I won't give a political answer to this one, right? Let me be very frank. It's always a problem. And that's why the environmental clearance, environment department comes into picture. This is not the problem until in your place also. I'm aware of some of the such issues because one of my colleague, he is somehow involved in this environment clearance team, right? And so I frequently talk to him, and he gets a lot of pressure from those people who are going for construction. So that conflict is always there, right? But then there are certain parameters on which you have to give the environmental clearance. So at the cost of environment, I think he is very, strict. And I have told him to be strict. At the cost of environment, if some construction is going to affect the environment, that should not be allowed. You find some alternate ways, right? Right? So that's very clear. Otherwise, we have paid so much already, and now nobody is going to tolerate this. So enough is enough. Okay. So you should not try to create the adverse environmental situation. You plan your construction activity such that the environment there is not affected. If it is getting affected, you think of some other ways or make changes in your construction plans, right? Or go for some other construction approaches. There could be options. There could be options, right? So whenever we try to do any projects, we look into different alternatives. Then the one alternative which affects the environment in a lesser way, with a lesser adverse impact. That's the one which is. Okay. I think.
Yeah, so but the minor constructions never require a clearance, like the small streams. So that's the big issue.
Yeah. So maybe if there are any specific suggestions, I will tell it to my friend, and then he can look into it. Okay. Okay. That's right. Yeah. Okay. So with that's okay. So Surya, what is the program now? We can visit few labs. Okay. Good. Yeah.
Now, I request our director to give a memento to Professor Ojha as a token of appreciation.
Okay. Wonderful. So my visit is again special because I came in the golden celebration. That's really wonderful. So nice of you. I'm really honored. Thank you very much.
Thank you, sir.
Okay.
I invite Dr. Srijit, Head of Forest Ecology Department, to deliver water.
Good afternoon. As a part of invited lecture series with respect to Golden Jubilee celebration, the NAR committee and Golden Jubilee committee was invited Professor Ojha, and he happily accepted our invitation and delivered and enlightened us on the aspect which we are not aware actually, because the hydrology things are not that much aware in this institute. So it was a great honor and privilege to be here today, and hopefully this will continue in future also, and definitely the researchers here can collaborate some programs with such a senior professor like Ojha and his team. And we are really thankful to you, sir, coming all of the way to here and deliver the important topic